And here is SOL topic number 11b, combinatorics. When it comes to combinatorics, we're talking about three things. Let's first talk about the fundamental counting principle. This says if we have one decision and it can be made m number of ways, and we have another decision that can be made n number of ways, then the two decisions together can be made by multiplying m times n. Basically, you find how many ways each event can happen and multiply those together, and that's how many ways both of them can happen at the same time. Permutations. A permutation is an arrangement of n objects, and we're taking r of them at a time in a specific order. For a permutation, order matters. Versus combinations. This is an arrangement of n objects taken r at a time, but this time the order is not important. For a combination, order does not matter. Now let's show you how to find this button on the Desmos calculator and this button on the Desmos calculator. Pull up your Desmos calculator and we're going to go into the keypad and go over to functions, and it's in the stats menu. We've got NCR for combinations and we have NPR for permutations. So that's where you can find it in the Desmos calculator. Let's look at our two examples. The first one, it says Maria bought a new bicycle lock. She must choose a code that consists of 3 digits. No digit can be used more than once, so there is no repetition. How many different 3-digit codes are possible? Okay, well, first let's talk about the number of digits we have. We have 10 digits, 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 digits to make up all of our numbers. Now we can attack this two different ways. I'm going to first look at the fundamental counting principle because I can see 3 different events. We're picking a 3-digit code, so picking the first digit, picking the second digit, and picking the third digit. So to pick the first digit, well, we have 10 digits, and I've got any one of those 10 could be my first digit. But it does say that no digit can be used more than once. So once I've picked the first digit, I only have 9 digits left to pick the second digit. And once I've picked the first 2 digits, I only have 8 digits left to pick the third digit. Each one of those events multiplied together gives me 720 different ways. And that is answer choice B. If you want to attack this with either a permutation or a combination, we need to know if the order matters or not. Well, this is a 3-digit code for a bicycle lock. And it very much matters that the order of the digits are the same as the code. So this is definitely a permutation. I'll do a big capital P. We have digits, and we're picking a 3-digit code, so we're using 3 of them at a time. And if I want to type in 10p3 into my Desmos calculator, I'm going to go to where the NPR is. When I click on that button, it's going to open up a parentheses. I'm putting a 10 and a 3, and I'm closing that parentheses. So the 10 and the 3 with the comma, that's how you type in a permutation. And we see our answer 720. So we got it right. This is a permutation because the order matters. Let's look at the second one. A box contains 8 tiles, each a different color, so 8 different colored tiles. Sally is going to select 2 tiles without replacement. How many different groups of 2 differently colored tiles could Sally choose? Well, is this a permutation or is this a combination? Well, let's think about it. If we're picking 2 colored tiles out of some random box, let's say one of them is blue, I pull that out, and then I pull out a red one. Would that be different than if I pulled the red one first and then the blue one? And the answer, of course, is no. The order does not matter. If I pull out a red and a blue, it didn't matter the order that I pulled them out. I have a group of red and blue tiles. So this is a combination because the order does not matter. Now let's see if we can get our 2 numbers. The first number is always how many things you have to choose from, and that's 8 tiles. The second number is a smaller number, or the same, I guess, and this time we're picking groups of 2, or choosing groups of 2. So it would just be 8 choose 2, or 8C2. So I just need to plug that into Desmos and I'll have my answer. So let's go to, I'll just close this one out, and let's go to functions, stats. This is NCR. Same thing, I need to put the 8, comma 2 into the parentheses, and I've got my answer of 28. There are 28 different combinations that this could happen, and that is also answer choice B. So remember how to find these buttons on your Desmos calculator. Remember that permutation, the order matters. Combination, the order does not matter. And if you can attack it with the fundamental counting principle just by finding how many ways each event can happen and multiplying those together, then try that. Thanks for watching this tutorial, and enjoy the problems we have on our practice set. Thank you.